Okay, today in IM2 we're going to talk about graphing in vertex form. So this is the vertex form of a line, but what does that tell you? Well, it tells you what the vertex is. These designate the vertex. So the important thing for you to remember, and I'm going to give you a couple of examples, is if you had a vertex of 2, 3, okay, then your graph would be x minus 2 plus 3. Notice that the 2 just gets put in, it's substituted for the h, and it is still minus. Remember when we talked about we would learn why it's negative to the right and positive to the left? Now you know why. Because this is saying it's a positive x. So it's going to go this way. Okay, so think about that. And now if your vertex was negative 2, negative 3, it would be x minus negative 2, like this, minus 3, or x plus 2. Now this is telling us to go left. That's why the positive tells us to go left. So hopefully that clears up something that we've been wondering about since IM1. Okay, so now I want you to think about this as a translation of this graph, of this basic graph. What is the translation? Okay, it's h units horizontally, because that's the one that goes this way, right? And it's k units vertically, up and down. Okay, and we just showed you examples of that here, so that should help. Okay, so in exercises 5 through 8, we're going to find the axis of symmetry. So first thing I notice is that I have a 2, and I don't have plus anything, so my axis of symmetry is x equals 2, and my vertex is 2, 0. Okay, over here on number 7, I have my axis of symmetry is 1, so x equals is 1, not negative 1, and my vertex is going to be 1, 4. Okay, so your turn. You get to do 6 and 8. So take a second and see how you do on those. Okay, so look at this one. This is a plus, which means negative 8 is my axis of symmetry, and my vertex is negative 8, and again we have nothing here, so it's 0. Over here we have a positive 1, so this is negative 1 is my axis of symmetry, and my vertex is going to be negative 1, negative 5. So hopefully you got those right. Go back and practice if you didn't. All right, so when you're graphing this, it's just showing you that when h is greater than 0, so when h is positive, you're going to move to the right, okay? When h is negative, that's this one, you're going to move to the left. Shows you in the green graph. So that's what we learned about when we have the x minus negative h, like that, okay? Okay, so now we're going to graph this one and we're going to compare it to the basic graph. So we've learned a lot of things about that, but first thing we're going to do is we're going to learn to graph using this. So we can plot the vertex right away. We can see that h is 4 and the k is 0, so here is our vertex. So we can plot the vertex. Then we want to find 2 more points on the graph. So usually you choose them on one side of the graph, so I'm just going to go with, since I know that my axis of symmetry is 4, I'm going to choose 2 more numbers on this side of my graph. So here's an example. They picked, so here's my axis of symmetry, which is 4. So they went and picked 2, and they picked 0. And they plugged those in and solved and got their values for the y's. And that gave them these 2 points. Then what they did was they reflected the points. Remember we talked about mirror points. The mirror points across here. So 1, 2, 1, 2, 1, 1. Now you've got your 5 points, and you can smooth out your graph and graph it properly. Okay, so this is telling you what if you have 2 things that are changing. So when you add the k in there, it's going to tell you if it goes up or down. So we're going to go over h and up k if if they're both positive. And if we had x plus h minus k, then that would tell us to go left and down, okay, because this would be negative h. Okay, in this slide they're asking you to compare a graph to an original graph. So here's my original graph, and then they're saying graph the f of x, and it's dependent on the g of x. So what they're saying in this example is take this graph and move it left 5. Okay, so that's what they did. They showed you the original graph in black, and then they moved it to the left 5. Well, that's kind of difficult to do. So what does that mean? So you could just graph the first one and then move it over, pick a few points and move them over, or you could look at the graph and say, okay, I'm taking the g of x, and I have plus 2, and I'm going to move it over, whoops, I forgot the x, you're going to move it over 5 more. And so that becomes negative 2, x plus 7 plus 3, and now when I set it up, my vertex is now negative 7, 3, so I know to move my graph over to here, and then you could plug in a couple more points, but essentially once you've got the vertex, then you just move any other points that you can find over 7 points to the left. Okay, so this gives you the new axis of symmetry and your vertex. Axis of symmetry is negative 7. The original axis of symmetry was negative 2. Okay, your original vertex was negative 2, 3. Okay, so here's some journal work, and we're going to compare the graph. So first of all, we have the basic graph. So what has happened? Well, they've added an a, and we know that the a is a stretch. So we're just going to say a stretch, okay, of 3. And then they want you to say what happened here. So we're going to go left 2. And here's the graph for that one. Okay, now let's try this one. We've got a whole bunch of stuff going on here. We've got a reflection, which means our graph is going to be a sad face. We've got a vertical shrink of 1/4, so our graph is going to get wider. We've got right 6 and up 4. So here's a graph explaining all of that, and that's what your graph would look like. Notice that it went up 4. Like I told you a couple days ago, you're going to always want to do your reflection first and then move up. So then you would take the whole graph and go up 1, 2, 3, 4. Okay, so usually they do everything in order. So they would do the reflection, then they would shrink it, then they would move to the side. Obviously this one didn't get moved over, but it would be more like this, okay, which is where that one is. Okay. All right, so this is in your journal. It's asking you to compare. Notice this is based on our original function. So again, we have to think of what is happening overall to the equation. So first thing I'm going to do is I'm going to go, okay, 3x plus 1 plus 2 squared minus 1, and I get my new equation, which looks like that, and there's my new graph. Okay, this is the original one, and so what would happen to my new graph? It would just be moving over this way, left 2. Okay, and that's the change that it already made. Okay, this is the new graph, not the original graph. Okay, so over here, the only thing that's happening is that I can see, they're comparing it to my original function, is a negative, which means my new function is going to look like that, and it's just going to be flipped over. Notice that the original graph would have been the opposite, and we just flipped it over there. So all of these changes were already in our original graph. All we did was flip it over. Okay, so one of the hardest things that kids do in this is these kind of problems, and there's a few of these on your homework, so I wanted to go over them really quick. So write a quadratic function in vertex form whose graph has the given vertex and passes through the given point. So the first thing I'm going to do is I'm going to go y equals, I don't know if I have an a, but I do know that my vertex is 1 squared plus 2. So the first thing I do is I put my vertex into the equation and I leave the a there. The next step is to put this point. It's giving me 1 point on my graph. I'm going to plug that point in to my equation. So I'm going to go 10, so I'm plugging in here, equals a. Then I'm going to put the x in there, 3 minus 1 squared plus 2. Okay, so I plugged in the new point there. Now I'm going to solve. 10 equals a, 3 minus 2 is 2, squared is 4, plus 2. I'm going to subtract 2 from both sides. I get 8 equals 4a. So a equals 2. So now I can write my equation. It's 2, so y equals 2 times x minus 1 squared plus 2. Pretty cool, huh? So let's start the second one. We start with our vertex, so be very careful writing down your vertex. This is 59. We're going to go y equals a, then we're going to go x minus negative 2, so it's plus 2 squared minus 4. Now we're going to add that point in, so I'm going to change the color so you see the difference. And we're going to go negative 6 is my y, a, my x is negative 1, plus 2 squared minus 4. So the new point goes in here. Make sure you put the y where the y goes and the x where the x goes. So now I'm going to solve for a. Negative 6 equals a times negative 2 plus 1 is 1 squared is 1 minus 4. I'm going to add 4 to both sides. I get negative 2 equals a. So the equation for the second one is y equals negative 2 x plus 2 squared minus 4. So finding the a was the trick we were always trying to solve for. Okay, now we're going to do 61, because these are on your homework, so I want to do a lot of examples for you. First thing we're going to do is write our equation, y equals, with our vertex in it, a x plus minus 5, because it's just a positive 5, and then minus, don't forget your square, minus 2. Okay, if you forget the square, it's going to mess you up. So now I'm going to put that point back in. Okay, so I'm going to go 0 is my y, and a, x is 7 minus 5 squared minus 2. So I get 0 equals a. This is 7 minus 5 is 2, 2 squared is 4, minus 2, and then I'm going to add the 2 over to the other side. I get 2 equals 4a. So, whoops, that's a 3. 2 equals 4a. So divide by 4, and a equals 1/2. Oh, so this one's a shrink. Y equals 1/2 times x minus 5 squared minus 2. And that's how you find the equation for each of those. Okay, so you might want to pause that and make sure you understand, but that is how you find those equations. Okay, the last thing on this video is the exit ticket. And when I put it in Edpuzzle, this will be there for you to solve and get those points. See you later.